All right, guys, I'm going to get started. Can I get a thumbs up that you hear me and see the board okay at home? Awesome. All right, welcome back, guys. I hope you had a good spring break. Get a little recharge going. If you remember, when we left for spring break, we were dividing polynomials. However, I had kind of broken that up into like categories. So we had seen the first two categories. We left with you guys doing that split method, where if it's one polynomial divided by a monomial, a single term polynomial, then you could just split it into a bunch of separate fractions. That's what we did right before we left. And I told you guys I was going to save the last type of division for this week because it's definitely more difficult. So guys, let me just put a little bit of disclaimer on today. Today is definitely like, whoa, that's a lot, Hardy. I get it. I just need you guys to see this because there is going to be a shortcut to everything I show you today, but I need you to see the long way just to prove to you guys that the shortcut tomorrow, it does work. So try to bear through today. I know it's going to be a lot, but again, I want to show you this so that the shortcut will make more sense tomorrow, all right? So what happens is, in today's type of division, it's basically going to be, well, what happens when you take a polynomial of more than one term and you divide it by another polynomial that is more than one term? Because now you can't use the split method. You can't split that up. So what happens is, in this case, you have to use long division. So what I would like to do first is I want to review long division with you guys with numbers before I make you guys do it with all of these variables and exponents and whatnot, all right? So let's review long division so that we can use it in these problems. So guys, what happens if I asked you to take 17,073 and divide it by 3, right? Well, we're trying to figure out how many times can 3 go into 17,073. So I'm setting you guys up for long division. Hopefully that looks familiar if you guys remember long division. Maybe you haven't even done it since elementary school. I don't know. All right, but here we go. So long division has all these steps. You divide, you multiply, you subtract, you bring down, and then you repeat it. You keep doing this over and over and over again, all right? So let's see. So first you would say divide. How many times can 3 go into 1? It can't. 1's not big enough. So then we go over to the next placeholder. How many times can 3 go into 17? Well, it can go in 5 times. So above the 7, we would write a 5. All right? That's the division step. Now you multiply. 5 times 3 is 15. Then you subtract to see what's left. It's 2. Then you bring down the next number and you do it all over again. All right, so now we divide. How many times can 3 go into 20? 6 times. So we put a 6. Now we multiply. 6 times 3 is 18. Now we subtract to see what's left over. It's 2. We bring down the next number and we do it all over again. How many times can 3 go into 27? 9 times, actually. So now we put a 9. Now we multiply. 9 times 3 is 27. Now we subtract. You actually get 0, which is always a great thing because we don't want anything to be left over, but we still have another number to bring down. So just keep bringing down the next number. And now we do it again. How many times can 3 go into 3? 1 time. So we put a 1. Now we multiply. 1 times 3 is 3. We subtract. We get nothing. And since there's nothing left to bring down, that means we're done. And to be left with nothing is the best case scenario. It means that 3 divided in evenly, and this represents your remainder, but there isn't a remainder. So the answer to this question is 17,073 divided by 3 is this. This is your quotient. This is your answer. You get 5,691. All right? And then don't forget, division can always be put back together using multiplication. So I should be able to take who I divided by, 3, multiply it with my answer, 5,691, and then that should get me back to the number that I was dividing into, 17,073. okay? Do you guys remember that? Do you guys remember long division? Because sometimes they taught you guys differently in elementary school. But guys at home, thumbs up, do you guys remember long division? Because I'm gonna ask you guys to do all of this now with variables and exponents. Guys, I'm not gonna lie. What we do today, it's long, it's big, it is a lot to take in. But just you stay organized and you pay in and you keep this process, okay? Divide, multiply, subtract, bring down, repeat. Okay, period. So now what I want to do is I want to show you what happens when you get a remainder, because the way you have to write your remainder with these polynomial division, guys, it's weird. So I want to show you why you're writing your remainder that way with numbers, because it's always easier to see what something means with numbers than it is variables. All right, so guys, look here. I'm just going to show you a remainder problem with a very small one. What if I asked you to do 34 divided by 8, right? How many times does 8 go into 34? Right? Well, how many times can 8 go into 3? It can't. So how many times can 8 go into 34? 4 times. So we put a 4, then we would multiply. 4 times 8 is 32. We would subtract. There's 2 left over. There's nothing to bring down, so that means you're done. So now this means that 2 is the leftover. It's what didn't fit. It's the remainder. So I feel like in elementary school, they always just made you write your answer. Your answer is 4. Remainder 2. They would always put like R2, I think, is always what they made you write. So that's your answer, right? So to put this back together, again, multiplication should put it back together, and then you just have to add on your remainder. So it makes sense that we should be able to take 8, what we divided by, times it with 4, your answer, add on the extra, the remainder, and then that should get you back to who you were dividing into, 34. And it does. 8 times 4 is 32, plus the 2 that didn't fit, and you get 34. Okay, the problem is, with polynomials, they do not want you to write your remainder as a separate piece from the answer. They want the answer and the remainder to be written as one expression, as one polynomial. So basically they want this. 8 times 4, the answer, plus the remainder, gets you back to 34. But the problem is, if you write it like that, it's not true, guys. If you try to write the remainder as part of the answer, this doesn't work, because 4 plus 2 is 6, and then 6 times 8 is 48. It doesn't get you back to the 34. So what happens is, if you want the remainder to be written as part of the answer, not separate, if you want it to be part of the answer, then you have to take the remainder and put it over who you divided by. And who do we divide by? 8. So guys, when you want the remainder to be written as part of the answer, you have to put the remainder over who you were dividing by, and in this case, 8. Because now watch this. If you distribute, 8 times 4 is 32, and then 8 times 2 over 8, the 8 on top and the 8 on bottom cancel, and you're just left with the plus 2. And then that will get you back to the 34 that you need. So if you start seeing some expressions with this like plus -3 over x minus 2, it's the remainder. They're going to write the remainder in this really weird way. They're going to write the remainder over who they divided by. And that's how you get it to be part of the answer as one whole expression. So I just wanted to show you that with numbers, so you can see when we start writing remainders, why the hell did she write it so weird? Because you have to. You have to write the remainder over who you divided by to make it one whole expression. Does that make sense? Is everybody okay with that? Okay. And maybe you even remember that from Algebra 1. All right, so here we go. So guys, last week, if we had more than one term divided by one term, then we could do it straight up or we could split it, and the answer didn't change. But guys, today, if you try dividing by more than one piece, right? We're dividing by 10 plus 15. We're supposed to get 1/5. If you try to split this, if you try to split the denominator, it doesn't get you the same answer. So you're not going to be allowed to use the split method when you're dividing by more than one term. So that's why today's problems, we're gonna have to use long division because we're gonna be dividing by more than one term. All right, let's give it a go. Let's see if we can do this. Hey, Flor, how are you, sweetie? Good? Did you have a good break?
Yeah, amazing.
I know, but it's over. I think spring break should be 2 weeks, if anybody wants to know. I could have used one more week. We're gonna get there. All right, here we go. So guys, look at this. If a polynomial of more than one term is divided by another polynomial of more than one term, no split, can't split. You're gonna have to use long division or the shortcut that I teach you tomorrow. But right now, long division. With long division, I just want to put a little note. You do have to look for missing terms. And sometimes, if there's a term missing, you're going to have to fill in a 0 as a placeholder. And I'll explain that when we get there, okay? All right, so look at example number 1. They want us to take this polynomial that has 1, 2, 3 terms and divide it by this polynomial that has 2 terms. So guys, right away, since I'm dividing by more than one term, I can't split this. I'm going to have to use long division. So we're trying to find out how many times does x minus 5 go into this polynomial. But hold on. Before you write this polynomial, see how it starts with an x squared? Well, missing terms would be if it starts with an x squared, then there's got to be a just x and a just number. And it does. It's not missing any terms. Whatever degree it starts at, you have to kind of count it down. X squared to just number. If this was an x to the third, then we need an x squared, a just x, and a just number. If this was an x to the fourth, then I would need an x to the third, an x squared, a just x, and a just number. Whatever that highest degree is, you have to count down from there, and you need a placeholder for every term beneath it, okay? But since this goes x squared, just x, just number, it's not missing any. We don't have to fill in any zeros, so we're good. So x squared plus 3x minus 40. So we're trying to figure this out. How many times does x minus 5 go into this polynomial? All right. So technically, we should divide, multiply, subtract, bring down, and repeat. That's long division. So how you get started is you should take the first term of this polynomial and ask yourself how many times it divides into the first term of this polynomial. So basically, how many times does x go into x squared? But sometimes that's a little hard to wrap your brain around, wait, what? I think of it like this. Think of it as multiplication. X times what gets you x squared? An x. So we need an x. So above your x's, because that's why the placeholding takes count, above your x's, give yourself an x. Because that's how many times x would go into x squared. All right, now we multiply, which is basically distributing. What's x times x? It's x squared. Guys, if these front pieces don't match, then you didn't put the right piece up here. You want this to match, so it cancels in the subtraction step. All right, but we're not done multiplying. X times x is x squared. What's x times negative 5? Negative 5x. So see how my x squareds and my x's all line up. Everything has a place. All right, so that's the multiplication step. Now we subtract, which is the hardest step out of this whole process because you have to remember to pick up that subtraction sign every single time. What does that mean? It means this. We're going to do x squared, subtract x squared, and they cancel. That's what we want. If they didn't cancel, we didn't do this right. All right, but now you have to pick up the subtraction again. It looks like, 3x subtract 5x is negative 2. It's not. Because it's 3 x's, pick up the subtraction, subtract negative 5. Guys, what happens when you subtract negative 5? It actually turns to addition, and now it's 3 plus 5, and it's 8x. So the subtraction will be the step that most people get wrong. It's not the dividing, it's not the multiplying, it's not the bringing down, it's the subtraction step. All right, now we bring down, and we do it again. Okay. So now technically you're trying to find how many times does x go into 8x. But guys, we're trying to match this. We're trying to get an 8x here. So just ask yourself, x times what could you put up here that gets you an 8x? X times what gets you 8x's? An 8. So in your numbers column, give yourself an 8. All right, so that's technically the divide step. Now we multiply. 8 times x is 8x. If they did not match, we didn't do this right. You always want the front ones to match. The other ones don't have to match, but the first ones do. All right, and then 8 times negative 5 is negative 40. Again, it's great that these ones match, but they didn't have to. Only the 8s had to match. These ones did not. All right, now we subtract, but we're going to pick up the subtraction each time. 8x, take away 8x is 0. They cancel. That's what we want. If they don't cancel, we didn't do it right. All right, and then negative 40, pick up the subtraction, subtract negative 40. What happens to subtracting a negative? It turns to plus, and lucky for us, these canceled too. They didn't have to, only those did. But they did, there's nothing left to bring down, so that means you have nothing left, which means your remainder is 0, which is what we hope we get. So that means when you take this polynomial and divide it by x minus 5, your answer is the polynomial x plus 8. This is what you would type into your answer box on Delta Math tonight. Your answer is x plus 8. And again, the remainder is 0, so there's no reason to talk about a remainder. Guys, I know that's like, whoa, it's a lot, and sometimes they get even bigger. You just got to take your time and really keep yourself organized. So guys, this should all go back together. I should be able to take who I divided by, x minus 5, times it with my answer, and it should equal who I divided into. So guys, if you FOIL this out, it should equal that, and it does. And that's how you know you divided it correctly, all right? All right, practice will make perfect, so let's try it again. Guys, are you okay? Is everybody okay here? It's a lot. Guys at home, can I get a thumbs up? Are you hanging in? You're doing great? Yes? All right. So look at this one. They want us to take this polynomial that has 1, 2, 3, 4 terms and divide it by a polynomial that is 2 terms. So right again, you can't split this. So how many times does x minus 4 go into? Now guys, take a peek at the polynomial we're dividing into. It's an x to the third, right? So there needs to be an x squared. There is. There needs to be a just x. There is. And there needs to be a just number. And there is. So there's no missing terms. I don't have to fill any zeros in. All right, so we're good to go. 2x to the third minus 13x squared plus 26x and then minus 24. All right, here we go. So technically we should divide first. How many times does x go into 2x to the third? But I can't think of it like that. I say, what can I put up here so that when I multiply it with x, it matches? I get a 2x to the third. So what times x gets me 2x to the third? A 2x squared. So above your x squareds, give yourself a 2x squared. All right, now let's multiply it in. 2x squared times x is 2x to the third. See how they match? If they didn't match, then we didn't pick the right guy to put up there. All right? And then 2x squared times negative 4 is negative 8x squared. Now we subtract. But don't forget to pick up the subtraction each time. So 2x to the third, take away 2x to the third, they cancel. That's what we want. If those front ones don't cancel, we didn't do it right. All right, now again, some kids are going to look at this like, oh, look, negative 21. It's negative 13x squared. Pick it up, subtract negative 8. What happens when you subtract a negative 8? It actually turns to plus, and you get negative 5x squared. And now we bring down. But guys, with polynomials, just bring everything down. And we're going to do it again. So again, now we're trying to match the front one, a negative 5x squared. We want them to match so they cancel. So how many times does x go into negative 5x squared? But I don't think of it like that. What could I put up here so that when I multiply it with x, I get negative 5x squared? A negative 5x. So above your x's, you need a negative 5x. See how everything placeholds, your x squareds, your x's, and we go. All right, so now we multiply it in. Negative 5x times x is negative 5x squared. See how they match? If they didn't match, we didn't do this right. All right, negative 5x times negative 4 is positive 20x. And now we subtract. We're going to pick up the subtraction each time. So negative 5x squared, subtract negative 5, that turns to plus, and they cancel. They have to cancel. If those front ones didn't cancel, we didn't do it right. All right, now again, some students are going to go, oh, look, 46x. But it's not 46x's. It's 26x's subtract 20. So what's 26 subtract 20? It's 6. You got 6 x's. And then you bring down, let's do it again. Okay, so guys, now we should be thinking how many times does x go into 6x? But I don't think of it like that. I'm trying to get a 6x here because I want the front ones to match when I subtract. So what could I put up here so that when I multiply it with x, I get a 6x? A 6. So we need a 6 as our number. So plus 6 should be above our numbers. All right, let's multiply it in. 6 times x is 6x. See how that matches? It's beautiful. That had to match. If we didn't, we got to go back and start over. All right, 6 times negative 4 is negative 24. These ones didn't have to match. It's just amazing when they do. All right, and then we subtract. All right, 6x. Take away 6x, that cancels. And then negative 24, subtract negative 24, turns to plus. They end up canceling too. There's nothing left to bring down, so you're left with nothing, which is the best, which means your remainder is 0, which means it divided evenly in. So guys, the answer to this is when this polynomial is divided by x minus 4, this is your answer polynomial. That is what you would type in to Delta Math as your answer. 2x squared minus 5x and plus 6. Okay? All right, now, I know I always run out of time here. I'm probably going to get this one set up, but I'm not going to have time to do it. So let me show you, well, what happens if you get a remainder? So guys, just for giggles, let's go back to this one. Pretend that when you did 6 times negative 4, and we got negative 24, just pretend, just so you can see what it looks like with a remainder. Pretend 6 times negative 4 was, let's say, negative 23. Just pretend that 6 times negative 4 is negative 23. So now, when you went to finish this problem, you would get 6x, take away 6x cancels. Negative 24, subtract negative 23 would turn to plus, but you would be left with negative 1, right? And then nothing left to bring down. So that means negative 1 is your remainder. But you can't just write r equals negative 1 at the end of the polynomial. So what they want you to do to make this remainder part of that expression, part of that polynomial, they're just going to make you take it and say, add it on. So plus the remainder is negative 1. And then you put it over, who did you divide by? X minus 4. So guys, believe it or not, that's what you would write into Delta Math if you had a remainder. You would add on the remainder, but you put the remainder over because it's a part of what you divided by. And that's what's so weird. So if you see that on Delta Math, you're like, what the hell is that at the end? Guys, it's the remainder. That's how they write the remainder. All right, but lucky for us, this one didn't actually have a remainder, so we'd be fine. I just wanted to show you what it looks like. Okay, so let me at least set this one up, and then I'm going to have to let you guys stop and go, because I'm going to run out of time. All right, look at this third example. All right, they want you to take this 1, 2, 3, 4, 4-term polynomial and divide it by x minus 3, a 2-term poly. So we can't split this, we got to divide it. So how many times can x minus 3 go into, now guys, look at the polynomial you're dividing into. it starts at an x to the fourth. So it's got to count down sequentially all those terms. It's got to go from an x to the fourth to an x to the third, but it doesn't. That means it's missing an x to the third term, which is fine. But guys, maybe our answer needs an x to the third term. So we have to leave a placeholder for that. So we're going to fill in 0 x's to the third because there aren't any. I don't want to change the problem, but we're going to placehold. So it goes x to the fourth, x third will fill in, x squared, just x, just number. So the only term it is missing is the x to the third. Sometimes it can miss 2 terms, and you got to fill in 2 zeros, all right? So now you would write it like this. 2x to the fourth plus 0x to the third, and then minus 15x squared minus 10x, and then plus 5. And then you go from there. You got to say how many times is x going to 2x to the fourth, or what could you put up here so that when you multiply it with x, you get a 2x to the fourth, okay? So you have to leave a placeholder for anything that might be missing, because if he doesn't have an x to the third, that's fine. But maybe our answer needs one, so we have to leave room for it just in case. All right, so I'll let you guys try this one. I always post pictures of your notes filled in on Google Classroom at the end of the day, so I'll have this one all worked out if you guys want to try it on your own, and then you can check your answer with my filled in notes. I suggest you do try this one on your own. See if you can do it, see if you can get down to the answer so that your homework hopefully will be that much smoother tonight. All right, so again, see if you can do this one. There is a homework on Delta Math. I gave you 5 questions to try, okay? And then tomorrow, hopefully we can jump into the shortcut. Because like I said, I know this is a lot, but it'll just be, I can now show you the shortcut, and you'll be like, oh my God, it really is doing the right thing. And you'll know that the shortcut is working. All right, let me double check your attendance, and then I'm gonna let you guys go. All right, if you have any questions, please stay on the meet and let me know.